Chapter 7.1 Absolute Value. Let's review the real number system. Starting in the center here, we have natural numbers. Those are also called the counting numbers, like 1, 2, 3, 4, etc. Then we have the whole numbers, which includes the natural numbers and 0. 0, 1, 2, 3, 4, etc. Next we have the integers, which is the whole numbers and negative whole numbers. So negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, etc. Then we have the rational numbers. These are numbers that can be written as fractions, which includes all integers, we can write any integer as a fraction by putting a 1 underneath it. For example, we could have negative 3 over 1, which just equals to negative 3. Some other examples of rational numbers, we could have 2 over 3, 8 over 7, negative 5 over 2, etc. Irrational numbers are numbers that can't be written as a fraction. Some examples are pi, square root 3, square root 2. So absolute value. The absolute value of a real number is its distance from 0 on the number line. Because we're talking about distance, it's going to be a positive always. If we look at some examples, the absolute value of negative 7, let's draw a number line, negative 7, negative 6, negative 5, negative 4, negative 3, negative 2, negative 1, and 0. To determine the absolute value of negative 7, we just count how many steps are we away from 0. So 1, 2, 3, 4, 5, 6. We are 7 steps away from 0, so the absolute value of negative 7 is 7. That would mean that the absolute value of negative 7 would also equal the absolute value of positive 7, because both of those numbers are 7 steps away from 0 on the number line. Let's do the absolute value of positive 3. We have 0, 1, 2, 3. We go 1, 2, 3 steps to get from 3 to 0, so the absolute value of 3 is 3. Write the real numbers in order from least to greatest. So first we're going to evaluate each of these numbers, and then we can order them. The first one is the absolute value of 3.5. How far away is that from 0? It would be 3.5 away from 0. Then we have negative 2, which is just negative 2. There's no absolute value symbol around it. Then we have the absolute value of negative 5.75. The absolute value of negative 5.75 would be how far is that away from 0, which would be 5.75. Then we have 1.05. Then we have the absolute value of negative 13 over 4, which would be positive 13 over 4. Let's figure out what that is as a decimal. 13 divide 4, we get 3.25. Then we have the absolute value of negative 0.5, which would be 0.5. Then we have negative 1.25, not absolute value, just negative 1.25. And last one is the absolute value of negative 3 and 1/3, which would be 3 and 1/3, which is 3.3 repeating. Now that we've evaluated, we can order them. We're ordering from least to greatest. What is our smallest number? We have a couple negatives in here. So our smallest number is negative 2. Then we have another negative, so I'm going to cross them out as I go. We have a negative 1.25. Now we have positives, so we want to look for the smallest positive number, which is 0.5. Next smallest positive, 3, 5, 1, 3, 3, so 1.05. Then we have 3, 5, 3, 3, so there's 3 numbers that start with 3. 3.5, 3.25, and 3.33 repeating. So 3.25 would be the next smallest. Then 3.3 repeating. And then 3.5. And then the last one would be 5.75. Evaluate the following: the absolute value of negative 4 plus the absolute value of negative 3. Let's evaluate the absolute value of negative 4. So we can think of it like brackets. We have to evaluate that thing first before we add them together. We get positive 4 plus the absolute value of negative 3 is positive 3. Add them together, we get 7. Next one, absolute value of negative 4 plus 3. So negative 4 plus 3 is inside the absolute value, which means we do that first. Absolute value of negative 4 plus 3 is negative 1. Absolute value of negative 1 is positive 1. Absolute value of negative 5 minus the absolute value of negative 2. Evaluate the absolute value of negative 5. It would be 5. Minus the absolute value of negative 2 is 2. 5 minus 2 is 3. Absolute value of negative 7 minus 10. We have to do the negative 7 minus 10 first because it's inside the absolute value. Negative 7 minus 10 is negative 17. Absolute value of negative 17 is positive 17. Absolute value of 12 times negative 3 squared plus 5 squared. Absolute value of 12. Negative 3 squared is 9. Plus 5 squared is 25. Twelve times 9 is 108. Absolute value of 108 plus 25. Plus 25 is 133. Absolute value of 133, which equals 133. Word problem. Maddox volunteers at a local hospital. One day, he takes the elevator from the 1st floor up to the 6th floor to see his supervisor. His list of tasks for that day sent him down to the 2nd floor to work in the gift shop, up to the 4th floor to visit with patients, and then down to the 1st floor to greet visitors. what is the total change in floors for Maddox that day? So because we're in the absolute value unit, we want to write an absolute value equation to solve this problem. We want to know the change in floors. When we want to know the change in something, that is subtraction. So we're going to be using subtraction, and we also want to use absolute value. Let's break this into each floor change. So he starts from the first floor and goes to the 6th floor. That would be our first absolute value. From floor number 1, subtract to floor number 6. So his starting location minus his ending location. Then we're going to add. He goes down to the 2nd floor. That's our second absolute value. He goes from floor number 6 to floor number 2. We're going to add the next one. He goes from floor number 2 up to the 4th floor to visit with patients. That would be our third absolute value. From floor number 2 to floor number 4. And finally, he goes from 4 down to the 1st floor to greet visitors, which is our 4th absolute value. He goes from 4 down to 1. Now we can evaluate. 1 minus 6 is absolute value of -5, plus 6 minus 2, absolute value of 4, plus 2 minus 4 is absolute value of -2, plus 4 minus 1 is absolute value of 3. Now we can evaluate each absolute value. Absolute value of -5 is 5, plus absolute value of 4 is 4, plus absolute value of -2 is 2, plus absolute value of 3 is 3. And then we can add them together. 5 plus 4 is 9, plus 2 is 11, plus 3 is 14. Maddox's total change in floors for the day is 14 floors. That brings us to the end of Chapter 7, Lesson 1.